everyone. Thank you for coming to my session. How many of you making AI? Anyone? Yeah, awesome, cool. So this talk going to be mainly about AI, and I will show some cool stuff. So let's start. A few words about me. I'm a Golang developer and tech lead at Converge. Converge, it's a machine learning platform. And we do a lot of Kubernetes stuff. Basically, we run on top of Kubernetes, our platform, and we make all this cloud native stuff, all this Kubernetes native stuff. And basically, what we do, we developing a lot of Kubernetes controllers, so operators, device plugins, and other cloud native tooling. I'm husband and father of 2 kids. And finally, I'm at the middle of my skipper course, which is really cool. And you have to try it if you did not yet. Okay, and this talk is going to be about, first of all, we will talk about containers and device sharing. And when I talk about device sharing, I imagine that any device that you have under /dev in your Linux machine, or it might be some virtual device, and we will talk about how containers sharing this device. Then we will talk about how Kubernetes make these shares and how Kubernetes manage these resources. We will do some live coding. We will run MetaGPU with debugger, and we will see how kubelet interact with this MetaGPU device plugin. And finally, we will talk about production-grade challenges for developing device plugins, basically. Okay, so first thing first is, I imagine you have a device and you wanna share this device between 2 different processes, right? And in this example is pretty simple. I'm creating a loopback file, and I would like to mount this loopback file to 3 different locations: MNT test 1, MNT test 2, and MNT test 3. Now, it's pretty simple example, right? And it's pretty obvious that I will be able to mount as a read-only to 2 different mount points, right? Like it's expected behavior. However, if I will try to mount this file to mount test 3, it will fail, right? And it will fail because I'm trying to mount this as a read-write. Now, this is really simple example, but what it can show us is actually the fact that sharing device, same physical device between different processes, depends on 2 things, right? We have this driver, the device driver, and the setup, the configuration. And for this example, I can share my single device as many times as I want until I do read-only. But if I will try to achieve the same when I do read-write, it will fail. With that, is the same will be true when I will talk about, right, this talk is about AI, and we are going to talk about GPU mainly. So if I will take the same concept, I have GPU, I have server, and this server has only 1 GPU card with 1 GPU unit. And I would like to try and check if I will be able to share this same GPU unit between 2 different Docker containers. Will it work or will it not work, right? So we do not know really until we will try. So let's try it actually. So I have this Docker command, Docker run command, and this Docker run command will spin up 2 containers. It will use exactly the same GPU 0. And inside this Docker command, I will run simple Python script, GPU test. This is TensorFlow hello world script, which just checking access to GPU and make some prints. So if I will try to run this one, let's see what will happen. Okay, I see at least 2 containers are started, probably started. But you do not really know if they started or not because I got some outputs here. But we can check. For example, let's see. All right, so we have this GPU -1. This is first container. Let's see what we will get inside the logs. And yeah, it's up and running, and it's printing some stuff. And this container does have access to GPU, which is cool, right? This is exactly what we want to see. And what about another one? Yeah, and another one is also in place. So I will able to share my GPU, right? Simple, expected, nothing special here. What will happen if I will run NVIDIA SMI command? Yeah, I have my two processes are in place. So this is cool. This is exactly what I want to have. All right, so let me clean up this. And now, how about Kubernetes? And it's pretty simple question, and the expected behavior that I would like to see that exactly the same setup will continue to work on Kubernetes. Is there any reason why it cannot work on Kubernetes exactly the same? And what is exactly the same behavior in this case? So my logic goes like that. I will able to share GPU device on Linux machine. I will able to achieve the same behavior with container run with Docker, right? And I know that Kubernetes is based on Linux basically, and on and it orchestrates containers. So it definitely should work on Kubernetes as well. So I will create this deployment, and I will create two replicas, exactly the same as I made with the Docker. And I will request one GPU device. And I would expect that this setup will be working exactly the same as it was with the Docker. So let me jump to the next pan. OK, so this is my deployment, right? This is my two replicas. And it is exactly the same Python script. And I'm asking for one GPU device. So what do you think? Will it be OK? Will it be running? Any thought? No. No, you know why? How do you sure? OK, so let's see. Let's see if you're right. So, OK, I will do create my two containers. Yeah, OK, so one is running, cool, right? One is running. Let's see what it's doing now. It's running. It's good. So I did 50% of the job. OK, but why second one is not running? What is going on? Oh, really? OK, but wait a second. Let me check. I can do describe. And I say, well, OK, it's saying that I do not have enough. But why? I mean, I have enough. Why Kubernetes is saying me that I do not have enough? I will able to run this on Docker. Why Kubernetes is saying me that I do not have enough? Maybe my two processes utilize 1% of the GPU. But no, Kubernetes does not care. Now, I'm a Kubernetes professional, right? I'm saying something wrong here. Someone did some bug during this development, and I do not like it because I'm a professional and I'm going to fix it. So let me fix this thing. And first of all, I need to clean up again. OK. So, and how I would fix it, I would say the following. I would say this limit that I saw in my deployment, I have a feeling that these limits make some trouble for me. And I will remove it. I will just remove it from deployment, right? And then I will say the following. Let me actually jump to the next pan. Yeah, so this is the diff. So I'm going to remove this one, these resources, because I'm a professional, I'm a real professional, and I got this feeling that this thing making trouble. So I'm going to remove it. You see, in this file, I'm removing it. And then, because I'm a professional and I know how to use Google, I did some Google, and I saw that if I will pass to the container this environment variable, visible devices, and I will specify the index of the GPU, this GPU will become available inside my container. Now, I'm a professional, I'm telling you, and I'm going to apply this. And let's see if this will work. Yeah, so I'm creating this one. Now I have two containers. Oh, and they both running. This is cool. What's my next step? Check the logs. All right, let's see the logs. Let's see the logs. One is OK. Let's see the second one. It's OK, guys. So what my next step here? I tell you what. I'm going to my manager, and I say to my manager, look at this. I am the man. Show me the money now. Right? Because there's a company and they were suffering years. They weren't able to share single GPU. And there was data scientists like talk to each other. Hey, I need GPU, please give me GPU. And then they got fight. And now I came to the company and I solved this problem. And like everyone, Dmitry, you are the man. You are the man, right? But not. Something is wrong here. Something is definitely wrong here. Something is going completely wrong. Okay. So let's see what can go wrong with it. Let me delete this one. Okay. So usually when we have Kubernetes, we probably have more than one node. And if today we have only one, maybe tomorrow we will have more than one. And then there will become, then we will face with the problem, which we will have different device specs, right? We can have 2 nodes or maybe 10 nodes, and each node have different GPU cards, and each GPU card have different amount of GPU units. So, and now I need to somehow solve this problem in terms of if I go with this way of specifying environment variables, it won't work, right? Because for specific node, I will specify 0. For other, I will specify some other numbers, and it will become unmanageable. The second problem is how to choose the right node, right? Because again, I have different cards, and now I need to manually specify on which node this deployment will be running. So we definitely want to avoid it. Another problem is how to calculate total capacity, right? Now, when I'm using Docker, it's quite naive, right? I have my node and I creating this bunch of containers, but how do I know where should I stop? Should I run 10 containers, 20? And this is also a problem that I need to address in some way. And finally, the healthy, right? We have many different cards, and they might become not healthy. So what you will do then? Like your data scientist will be scheduled, will be deploy manifest, and the GPU is not healthy, and nothing is running, and yeah, it's becoming a problem. Okay, so with that, what Kubernetes does provide for us out of the box, basically. Kubernetes provides some resource management for us. And this is really cool, right? It might be not obvious from the first glance, but for example, having this ability of CPU management, very powerful, right? Because you have this kubelet on each node, and kubelet know what are the total CPU allocatable. And then you can create your deployment manifests and make this made the things right? So and the same for the memory. We have all this memory and we can manage it. Finally, we have ephemeral storage and huge pages, and all this stuff provided for us out of the box by Kubernetes developers. Obviously, what they cannot provide for us, it's all the others resources that might came. And what kind of resources it could be? So one of them is GPU, obviously, we are talking about GPU, but you can imagine anything basically. You might have network card, right? You might have some, for example, 5G networks now, which trying to utilize Kubernetes, and I might have 2 network cards, one for the control plane and another for the data plane, and my data plane is might be voice streaming, and I would like to prioritize this traffic, for example. And for example, I can say I have my network card, and this network card should be shared by 3 pods maximum, for example. This is example of custom resource that might be on any Kubernetes node. But how you can achieve this? I mean, how you can extend your Kubernetes? And this is the answer, basically. To extend Kubernetes, or what officially called custom node resource, you need to use device plugin framework. With this device plugin framework, you can achieve any functionality, basically, that may came to your mind. The device plugin framework is based on gRPC. What does it mean is you probably better to be familiar with gRPC concept. Nothing complex really, but it is important to understand the basics. The second thing that you need to be aware of is the communication is done through Unix socket. So you have this node, you have kubelet, which is running on this node, and you have two Unix sockets. One Unix socket belongs to the device plugin, and another Unix socket belongs to your device plugin. To one to the kubelet device plugin, and another to your device plugin, and they talk to each other through this Unix socket. So you need to implement a few methods. It's basically 5 methods that you need to implement as a part of your gRPC service. And you need to implement one client registration call to the kubelet. All right? And once you're implementing all this functionality, you will be able to achieve exactly or pretty similar behavior as you have with the out-of-the-box resources. For example, the CPU, right? The CPU management, memory management, and you can get the same. You can plan the total capacity. You can plan how exactly you want to share your device, what are the maximum pieces of your device, and so on. So if we will do a more detailed explanation, it will go like that. You write your device plugin. Usually you write it in Go, but obviously you're not limited to Go. It's gRPC, and gRPC is language agnostic. You can write it in any language, but it's very simple to start with Go because you have many examples and many libraries. So you're implementing these 5 methods. Okay, you just go and implement these 5 methods. And once this is done, you build your device plugin. So you have this binary, and you put it on the node where your GPU is running. The next thing you need to do, you need to execute a register call to kubelet socket. You say, hey kubelet, I'm a new device plugin. My name is MetaGPU, and please meet me. Hello, this is me, basically. So what kubelet will do, he will execute this registration logic. And once the registration finished successfully, kubelet will make basically two main RPC calls back to my device plugin. The first one, list and watch. The second one is allocate. So when kubelet will make list and watch, we need to respond to the kubelet and say, hey kubelet, I have 10 devices, for example. My ID devices is like that, and all my devices are healthy. Now, list and watch RPC call, it is streaming RPC call, which means you have this connectivity always open. And if something is changing, which in your devices, you need to reflect it back to the device plugin. For example, if for some reason you're deciding that one of the devices that you are managing become unhealthy, you will stream this event right away to the kubelet, back to the kubelet, and kubelet will advertise this change to the nodes, to the kubelet, and to the scheduler, and then to Kubernetes API. All right, I was pretty fast. Now let's see it live. I talked a lot, but let's see it happens. So what we have here is the following. You see this is capacity, right? The node capacity. I hope it's like you're familiar with this, right? You know what is it. So you have this capacity, and this is something classical that you will see on any Kubernetes cluster. You will describe nodes, and you will see these values. So we have this capacity and allocatable, right? By the way, allocatable and capacity, right? Not all the capacity are allocatable, right? And this is cool, but this is not exactly what I want. I want to extend this list, okay? I want this list to include my resource, which I will call MetaGPU. So, and to achieve this, what I will need to do is I will need to open my IntelliJ. and I need to start to write some code, right? But I already wrote some code. Okay, so this is the 5 methods that you need to implement, basically. This is how they look like. And you can find a bunch of documentations in the internet and so on and so on. But the one that's interesting for us for now is the list and watch. So you can see I make some logic here, but at the end I need to stream these devices. So when when kubelet will call to me, I will send back to him these devices, okay? And I will put this breakpoint and we will see it in live actually. So let me run it. So I'm making here remote debugging, but it's okay. So let's see. Yeah, you see now my device plugin up and running, and hopefully you see this well. But I have this device list, and you see total capacity of 100. And each device looks like that. It's some ID, which is string, and then string healthy or not healthy. So I'm going to say, Kubernetes, please meet. This is 100 devices that I will advertise to you. So let me continue with this. And now my device plugin is running. Let me go back to this panel. And you see now we have this Converge.io 100 MetaGPUs. Okay, so we were able to extend Kubernetes custom nodes resources, right? So I can call it whatever I want. I can have, I don't know, Dmitry device plugins, foobar, whatever you want. And now let's see the real power of it. Because now, if I will, Vim. If I will go back to the beginning of my presentation where I wasn't able to use limit, right? I wasn't able to use limit and resources and spin up 2 containers. I will try now to make this, but this time I will try to make it right? So I have these 2 replicas. But this time, I'm not going to request for GPU, but I'm going to request for the MetaGPU, and I will request 50. Now, I splitted my CPU, my GPU to 100, so I have now 50, right? And another 50 because I have 2 containers. So let me create this one. Like that. And let's see if I will be able to. Okay, my 2 containers are running, and they're running the right way, right? They are running, and I am now managing these resources in the right way. So now I really can go to my manager and say, hey, you know what? Now I am able to manage the things right. I'm able to plan it basically, because now I can say, okay, you can run 2 containers which using half GPU and half GPU, or maybe I can say, you know what, I want to split it differently. So I will go and edit this deployment, and I will say, you know what, you do not need 50 meta GPUs, which is mean you do not need half, you do not need 50%, but maybe you need only 51 won't work. Yes, but yeah, and this is really interesting, but it's not for this session. The thing is, you can easily extend this, like change this number. So now, if I will, let me edit it, and so I will. You know what? I will go and I will scale it to 3 now. And all my 3 will be able to run, right? Because now I have 20, 20, 20, so I even can scale it even to 5. And this is exactly what I want, basically. I want this ability to manage resources right, okay? I want this ability to provide healthiness, to calculate capacity. Cool. So
this driver is written by your company, or is something?
It's this device plugin written by me, and I'm working for the company, and it's open source, MIT, and you're all welcome to use it, contribute, and so on. production grade features. So all this nice, but when you will when you really want to make things at production level, you might ask yourself, okay, what about max utilization? My GPUs are expensive, and I want to utilize it as much as I can, and it might be not straightforward, right? Because today I might have process which takes 100 GPU, and tomorrow I might have many processes which takes, I don't know, 1% of GPU. So we need to address this in some way. Limit enforcement. Now when we're sharing, the way this resource is shared, it's not at the hardware level, right? So which means basically that two workloads which utilizing GPU, who will make sure that they are using exactly half and not more than that, right? So we need to address this as well in certain ways. We definitely want to make dynamic resharing. There is nothing static, right? There's nothing permanent in our universe. And we would like to change this configuration dynamically. And for example, so for this example, I did 100 meta GPUs, but maybe it's not good enough for tomorrow, and I would like to share it to 2,000, which is also possible. Finally, it should be easy. We should be able to easily use it, because there are some other projects. If you're familiar with the MIG, NVIDIA MIG, and so on, it's not straightforward to configure it, and you need to reboot servers. You need to, and after the reboot, you probably need to, when you're changing the sharing, you need to kill all processes which using GPU. So the goal of this project is to make it really easy to use. Thank you. That's all. Any questions? Please go ahead. The GitHub. So.
How did you decide the number 100? If I have 8 cores, what should be the number I choose? You said it could be 2,000, it could be also 100.
Yeah, so what we did, Converge, just I will open this MetaGPU. This is the project, it's licensed under MIT. Not yet. It's just because we do not have unit tests, because so we cannot. I'm joking. No, it's not. We have only 9 stars. Nice. Anyway, so the way we sharing it, it's like that. The sharing configuration is completely dynamic. The way it's behaved by default, we taking each GPU. So, for example, you have a card with the 4 GPUs. So the total amount of meta GPUs will be 400. So if you want GPU and a half, so you will allocate 150 meta GPUs. Oh, right. Now we have some. For example, someone created here an issue. This is the first issue that we, and the only one that we have. But and these guys asking like that. What if I wanna have some ability to using 50%, for example, of my 4 GPUs, something like that. Another use case might be, what if I have some data science who work on some important project, and I want to allocate only for him certain GPU for a week, right? So this is exactly where we can implement this. We can achieve this. And what if I will build on top of it UI, right? And I will provide this nice UI. So you'll go and open website, and you like click, I want for Chaim, I want this, and for David, I want something else. Yeah, so any questions? We have 10 minutes. Yeah.
Is this presentation recorded somehow, or watch it again anywhere? You made this?
Yeah, we did record it. We'll go it right here, and in a few weeks it will be available like all the other content.
Thank you.
And when you watch, after you will watch this presentation, you will learn Device Plugin, come and contribute. Cool. Yeah.
So if a pod goes to some GPU limit, can it trigger the HPA and scale and have new pods?
This is a good question. Not. so not yet, but we can achieve this, right? What we achieved, and I'm just not showing this inside the presentation. We do limit memory, and we do provide management CTL, which is very nice. So you can actually contact your Meta GPU, and you can manage remotely. We do provide, you know what? Let me just show you the CMD. We have this. What we do, around the tooling, what we have is these three binaries. So we have Meta GPU Exporter, which is Kubernetes native. It's provide a lot of more information than DCGM, the NVIDIA DCGM. We have this device plugin, and we have this management CTL. For example, so I can manage my GPU device remotely. I can sit on my computer, and because it's using gRPC, I can manage all my GPUs on the cluster from my PC, for example. Yeah, but regarding the HPA, no, we did not implement it yet.
What about memory allocation?
So yeah, so memory allocation, we are not allocating memory. We enforcing the memory.
Is there a memory per GPU or something like that?
Yeah, so what we're suggesting is the following. I will show you. Yeah, so what we are saying is you probably better to specify your limit in your workloads like that. Yeah. Yeah. GPU memory. Because if you will not do this, we will kill your process, basically.
If you will consume more memory than it
Yes.
allocated?
Yeah, it will be killed. Now it will.
Out of memory.
Yeah, it will be killed. It will be killed. But it's not really out of memory, because when I split my GPU to 2 slices, and for example, each slice equal 2 gig of memory, so I have total 4. But if you requested 2 gig of memory, I will see this. Like this MetaGPU plugin will monitor the amount of consumed memory and the total amount of shares. And if you are going beyond the shares that you have, there's 2 options. It might be killed, or we can just send some notification, something like that.
What about metrics? Does your code support metrics?
Yeah. We do have metrics, and this is really nice thing. We have this.
You can define HPA on based on metrics, no?
Probably yes. I think we did not test it, never. But I believe, you know what? I believe, yeah, it should work HPA, because we have auto scaling in AWS, and yeah, it's based on that. So yeah, it's just not. I just didn't work it on this one. So I believe our DevOps guys were able to scale it out. Yeah, because we have scale to 0, and when someone requests Meta GPU, right. So I believe this is exactly that. So regarding these metrics, we have this exporter, and what kind of metrics we have?
I can ship the metrics to third party.
Yeah, it's Prometheus exporter. Yeah, it's Prometheus exporter, and for example, we have this absolute GPU utilization, memory usage per process. We have this max allowed GPU utilization, all these metrics available, and we have small, but we have this docs. It's not too much, but you know. Yes, it will work on anything where your Kubernetes cluster is running. You need to deploy this as a daemon set, and you will have it. Yeah.
So with all this polling and communicating to the GPU, do you actually take a fraction of the GPU utilization while running this controller, and if so, how much?
Exactly. So. And no, this is not what we're doing. What we do is pretty similar to the way of CPU is working. Like when you running process on CPU, right? It's just running on CPU, and the Linux basically know how to allocate the amount of CPU time, right? And in Kubernetes, it will be managed by C groups, right? The control groups. Now, for GPU, we do not have control groups. So we have two options. We have completely software level option, very simple and naive. And this is one which we are using. Like, for example, each 10 seconds, I will get all the processes that running on my GPU 0, and I will calculate, I will get the real amount of memory they are using and what they should use. For example, so if I allocated 50 meta GPUs and they equal 2 gig of memory, so this process cannot use more than 2 gig memory. And then I will just kill it, or I can, it's configurable. So I will either kill it or I will issue some event. Hopefully this is clear.
And where do you save this persistence? If it crashes, then...
Yeah, this is good, because the nice thing is, you know what, really the nice thing, when you start, like GPU and basically all this NVIDIA, they not really Kubernetes awareness, they're not really Kubernetes native. So the way, but they are good guys, I have to say. and my company was acquired by Intel, so but still they're really good guys. So I have two sources of truth. I'm using this Go NVML management that NVIDIA kindly provide for me, and this thing give me interface to talk to my GPUs. So you can basically take this one and you can just get a bunch of information for you. Utilization, anything basically. The device type, is it healthy or not, and so on and so on. So from the one hand, I'm taking this NVML library and I'm saying, hey NVIDIA, say what is the processes are running and what is amount of each process. And this is one piece. Another piece is Kubernetes. So I make this merge between Kubernetes and NVIDIA, what they expose for me. And based on that, I'm deciding if process that running inside container should be killed or not.
If, for example, I set 100 initially, and after I updated the amount of nodes, it will use all new GPU instances?
It will automatically advertise, yeah, exactly. It will happen exactly in this place, this listen watch.
So it's not need to update manifest, etc.
You do not need nothing, yeah. This was it should be usable and simple of use. This is exactly what the main goal was. Thank you, guys.